We're going to change the order of integration. Here we have the double integral of, here is just 1, but could be any function from 0 to 1 in the x, and from 2 to 4 minus 2x in the y direction. So we read this as the double integral from 0 to 1 of the integral of from 2 to 4 minus 2x of 1, or you could just say of dy dx. So this integral is for the y, or with respect to y, this, and next you do this. Here we are not going to evaluate the integration. We have videos of this, and this is simple. The difficult part is what if we want to change the order of integration. That is, we are going to end up with a double integral that now ends up being first dx and next dy. So just as a hint, here we are going to have a function of y, as here we have a function of x. Here we are going to have the limits of x in functions of y, and here just numbers of y, like here we have numbers of x. If you think you can do it, stop the video now, and let's continue to see we have the same result. Alright, so first, the simpler way to do it, I think, I put 0 is less or equal than x, less or equal than 1. For y is 2 is lesser or equal to 1, lesser or equal to 4 minus 2x. First we're going to do it analytically, and then we're going to see a little of geometry about this. So I'm going to put x in terms of y. So with this, we don't have anything to do. But with this, we have y lesser or equal to 4 minus 2x. So y minus 4 lesser or equal to minus 2x. Switch signs, minus y plus 4 lesser or equal to 2x. Oh, sorry, greater or equal to 2x. When you switch sign, you need to change this inequality. So 4 minus y divided by 2 is greater or equal to x. So because this is greater than x, this goes in the superior bound of the integral. So here we have 4 minus y divided by 2. So this corresponds to this one. Here we cannot evaluate this in terms of x, we cannot put the x in terms of y, because here we don't have x in this inequality. But we are missing the lower bound. This lower bound is 0. So you put from 0 to 4 minus y divided by 2. Next, here, when x is equal to 0, you have 4 minus 0 is 4. This you cannot plug 0 here because there is no x. So when x is equal to 0, y is equal to 4. And when x is equal to 1, y is equal to 4 minus 2 is 2. So y is 2 and 4, goes from 2 to 4 or from 4 to 2. We yet do not know which one are we going to put here. First, I'm going to do it geometrically in order to see why. First, algebraically, I know I'm going to explain why it is in a minute. If x goes from 0 to 1, this corresponds in y to 4 and 2. I exchange them. Goes from 2 to 4. This is because let's put the limits of integration. Here we are just integrating the function 1, but we are integrating between 0 and 1. So let me graph it. X goes from 0 to 1 and 0, and y goes from y equals to 2. Here is y equals to 2, and 4 minus 2x is minus 2x, has a slope like this, cuts in 4. So like this. It's something like this. The important is that we are going from here to here. We are sketching, let's say, this region from 0 to 1, and from 2 to 4 is this region that we are integrating, well, the region that we are finding. Alright, so we go from 0 to 1, 0 to 1 in this direction. That is, if you look the integration in x, you go from here to here, you go in this direction. In this direction. So for that, the 1 goes on top and the 0 goes on the bottom. Next, in y, you go, instead of from left to right, you go from bottom to top. You go in this direction. So 2, and the upper bound is 4 minus 2x. That is this point. If you want to switch the order, you want to put y here at the end and with numbers. So, from 2 to 4. Here you put 2 and here you put 4. And in x, you put this point is just corresponds to x equals to 0. There is no function of x and y. And this corresponds to this line, that is, in terms of x, is x equals to 4 minus y divided by 2. This is the value of this. The important thing is you go from left to right in the x direction, and you go from bottom to top in the y direction. Here, when you have the lowest value of x, you are in the highest value of y. So if you begin here with 0 in the x, when you do y here, when you're going to put y here, you need to put this value that corresponds to the x in y. 0 corresponds to 4. When x equals to 0, y is equal to 4. So you need to put this bound here in the top of the y, because this x equals 0 corresponds to y equals 4. Here x equals 1 corresponds to y equals 2. So y equals 2, and because you go from 2 to 4, you put first the corresponding of 1, that is 2, and the next the corresponding of 0, that is 4. This is going to be exactly the same for any of the problems that we're going to do. This is always like that. You go from left to right and from bottom to top. And we are going to do next exercises the same way as we did in the algebraic form. That is, I do this, the inequalities, and next I know that the x's and y's, I switch the boundaries. The upper of the x goes in the bottom of the y, and vice versa. And next we're going to do the geometry in order to see that always this is like the same. We need to exchange if here 0 corresponds to 4, we're not going to put 4 here, we're going to put it here. So like you switch like this. And we're going to do a lot of exercises on this in order to have clear the method of how to do it. And just the answer was integral from 2 to 4 of the integral from 0 to 4 minus y divided by 2 dx dy.